So in our IoT solution, one of the things that we've done is we built a integrity smart contract for different IoT devices. And so I won't walk you through the whole entire smart contract here, but I'll kind of walk you through the gist of the solutions. And the solution is available as open source from Dragonchain for you to build on top of the chain. We haven't put it to the GitHub yet, but it will be available. So if you need to get it sooner than later, reach out to us. The software integrity contract runs on Dragonchain, allows you to have different versions of software ledgered onto the chain and then authorized over a period of time. So it's like having each submitter can authorize and sign for their approval and give their private key to approve for that stage. And so for example, an organization may have a developer that may need to be able to sign to say that, okay, I actually created the code. You may have someone in test be able to say that I did a QA on the code itself. And you may have someone in security or governance or another group sign off on the release for the code itself. And each of those individuals can sign, or maybe two of the three different solutions can sign within a period of time to be able to release the software. And so what we do is we build a software tracker. And so what we can do is build containerize the code repository, and so we've created a tracker on there. In this case, what we've done is we push out the software itself. We have the image URL, and we can deploy the contract onto the Dragonchain. We deploy the contract out, and then we can start to sign the contracts through each of the different chains. And so we can actually have integrity over the chain of custody of how the code was released into the process. So the first step is to get the latest SDK. We then push out the SDK out to the solution. We register for a Dragonchain console. We then get a list of approvals of who's allowed to approve a list of approvers for the system itself. And then once we have those approvers, like in this case, we have the payload of the different individuals. They can go through and add new keys to each of those approvers, so we can match up the keys to say this person with this private key is that signs it is approved, and then we can validate each of those different solutions. And so this is really important in the deployment of IoT devices as we think about the things that we've been seeing with like rooted video cameras and untrusted firmware that's happening on things like video cameras and other IoT devices out there. Being able to track the process in which firmware was written and deployed is really critical to be able to deploy these solutions. And so it's one of the neat things that we're able to do. The other thing that's kind of neat about IoT devices is new definition of where computing is being done, whether it's being done out on the edge, whether it's being done out in the compute, or whether it's being done out in your own on-premise data centers. We're seeing new models of ways that people are deploying these solutions with AI arising in conjunction with IoT. We see new sets of data being pulled out there. And so smart contracts can allow you to move and share algorithms in new different models. So for example, with IoT devices, lots of data may be produced out on different edge devices, whether the edge is a metro edge, or whether it's the actual IoT devices, or or different new topologies that are arising, we can start to push algorithms out to that data itself, where it may make more sense to filter and reduce some of that data sets, or make decisions on the data at the point where it's collected. And so one of the things that we realize is that it's not always the same parties or the same companies that are building the algorithms that are wanting to use the algorithms. But there's a trust problem or trust challenge of being able to use those algorithms in different environments, and making sure that they're confidential, that they're not being stolen, that the intellectual property is protected, that the data is being protected, and that you're not shipping private, personal, or sensitive data around to third parties. And so what we can do with smart contracts is we can take a Dragonchain and pull it up adjacent to the information that's being collected by those IoT devices, and take smart contracts and allow for a platform for different parties to bring their data and their algorithms together in a confidential computing type environment to bring those data together. I've been playing a little bit with homeomorphic encryption, and being able to take data and information and being able to exchange it confidentially without parties knowing each other's secrets, yet getting the output of the actual algorithms being executed. And so now there's homeomorphic encryption, which is fantastic, which blockchain is really unlocking, as being able to take out the trusted entities, and rely on protocols and technology itself as the mediation platform. But algorithms can be weakened, they can have vulnerabilities, and so by using Dragonchain and smart contracts, we can break up that algorithm and have both the process enforced through smart contracts and the business logic of the exchange, and then combine that together with the technology of homeomorphic encryption to be able to provide the encryption controls and the protection from a algorithmic standpoint to protect it. And so by layering those on, we really combine and hit really a sweet spot in where we see compute happening at the edge on IoT devices. There's other interesting things that we're doing with IoT, in the fact that we have decentralized identity with our Dragon Factor solution. Our Dragon Factor solution, we've been making a lot of progress in that solution, and being able to create a private key, being able to validate who you are, being able to have third-party verifications or attestations of who you are. And if you apply that to the IoT world, it allows you to have devices that are owned by individuals. So me as an individual can own an IoT device, and that IoT device can sign or verify different types of environmental environments or information, and pass that through a validated standpoint. By using decentralized identity, it allows us to take out third-party validations and allows us to do peer-to-peer communications in a way that's much more efficient and doesn't require third parties to be involved in our transactions. And so it's a really neat ability to verify and validate transactions that are happening from IoT devices in a really lightweight, low footprint type of solution. I think there's going to be lots of interesting things that we're able to do with the negotiation and being able to have like IoT devices use that decentralized identity to be able to access secure stores. So an IoT device can actually access things like a data store or a vault of information for that IoT device. We can have things like provenance and location history of those IoT devices. So we can better rely on the data that's being produced by these devices. So if you're interested in working more with blockchain and IoT devices, come reach out to Dragonchain. We have consulting services that we can help you figure out and deploy these solutions. We can help validate transactions. We can help validate the firmware and the release of those softwares. We can help with bringing different compute and processes together, so bringing algorithms together with the data and being able to mine that data in a way that makes sense and react to it through data streams. And so I'm going to go ahead and log out now. We'll go to a break in 15 minutes. Be sure to tune in. Jonathan is going to be walking us through the patent process. He has lots of valuable information. Every time I talk to him, I learn something new. So don't miss it. Jonathan's amazing.